Hey, what is up guys? Welcome back to another video, and in this video we're going to be continuing on with our SwiftUI tutorial series, and in this particular tutorial we are going to be taking a look at how we can update stuff in our database from our client-side application by sending a network request to an API. Now, again, much like the last couple videos, I will be using a custom Vapor API that I built. It's a very simple API just for demonstrating how network requests work. If you want to take a look at that API, the link for that is in the description down below. So you can take a look at that. Now, with that being said, what all is necessary to send network requests to update something in our database? Well, that requires one of two different HTTP methods, depending on how you want to update a record. You have put and patch. Those are the two HTTP methods that you can choose. They're pretty much interchangeable, but according to the HTTP REST spec, or the rough guidelines that go along with REST, put is meant for updating an entire record, whereas patch is intended for updating part of a record, right? But again, you could use either or for whichever. It doesn't particularly matter too much, but if you want to remain if you want to follow the guidelines exactly, then put is for the entire object, patch is for part of it. All right. Now that means in our network manager, we're going to have, again, another method for updating our record. If you want to update part of a record in one place but an entire record in another, then that would require two new methods. It really depends on how you want to do it. The way that we're going to go through it today works in both cases. You just have to do a little bit more work for updating the entire record. Because, well, you have to update all the properties on the object and then send that updated data up to the server. So, with that being said, let's go over to our API, because I want to show you the model on the server that is used to represent what the server expects when you send your patch requests. So I'm going to go into Xcode, and I want. Okay, so it looks like I don't have the API open. That can easily be solved. I am going to say cd desktop / sample bug tracker API, and then we want to open package.swift, like that. All right, so here we are inside of our API. I'm going to go into my DTOs. So that'll be under sources, under app, and then under DTOs, we have patch project DTO. That's the one we want. So here we are inside of our patch project DTO. All this model is going to take is the is closed. right? So is closed is the only property for this DTO, because when we send a patch request for a project, I'm having this only update part of a record, and is closed is the only patch request we want to actually have. Everything else should be done in a put request. Now, what does the patch bug report model look like? Because we also have that. So patch bug report DTO. This will expect a report type, and that's it. So if you want to update only part of a bug report, the patch request for that will expect that you update the report type. And the report type, as you can see, is lowercase r report, uppercase T type. Just like is closed is lowercase is, uppercase closed. All right. So those are the two patch models. We're only going to work with sending a patch request for projects. I'm going to leave sending patch requests for bug reports up to you. So we will now go to our controllers. And we'll take a look at the project controller. Up here at the top, let's take a look at what endpoint we're going to be working with, because that is going to be very important as we move forward. So inside of our project controller, you can see here up at the top, we have projects get, projects post, projects get, projects delete, projects patch, and projects put. Now, we want projects patch. The API endpoint that we're going to get is /API/projects/update status. And then we want to give it the project ID. So if we go into, well, let's go to a blank line here. So let's create a comment here. So for our put endpoint, or rather our patch endpoint, I should say, our URL, our endpoint, will look something like this: http://localhost 8080/API/project/update-status/ and then the ID of the project. So / whatever the ID of the project is. So the server will know, oh, okay, this is the project we want to update. We want to find the project in the database with this ID and then update its isClosed value to what I was given in the request body, along with the ID. Now the ID doesn't update because that is never supposed to change, but only the isClosed property will change. The ID is simply there to allow for querying the database for the right project to modify. All right. So that's it for looking at our API. Let's go ahead and go back into our client-side app and write the networking code necessary to make this work. So inside of my tutorial app, I'm going to go to our models directory. under models, we're going to go new empty file, and I'm going to call this patch project. All right, import foundation, because we're going to need foundation. I'm going to get rid of the comments here up top. Next, we're actually going to create a structure for this. So struct patch project. Now, we are not going to have this conform to identifiable, but what we are going to have this structure conform to is encodable. Now, why not codable? Well, the reason why we're not going to conform to codable is because we're not going to decode this JSON to a Swift object. All we want to do with this object is we only want to be able to encode it to JSON. So if we conform to codable, we're wasting a protocol conformance that doesn't need to be there. So we can save ourselves a little bit of trouble by only conforming to encodable. So encodable, like that. Granted, there really isn't any performance hit when doing that, but it just simply doesn't make a whole lot of sense in the grand scheme of things to conform to something that you're not going to actually use. All right. Now, the only property this is going to have is going to be the all that's going to be inside of this is the isClosed property. So var is closed, and that's going to be a Boolean. And there we go. That is that model complete. Now we're going to go to our network manager and begin writing our code. So network manager. Let's go down to the bottom of our network manager file. And then we're going to create a little bit more room to work with here, just so it's a little bit easier for you guys to see. All right. So now we're going to create a function called update status for project. And then we're going to take in what the new isClosed property should be. So there's going to be two parameters here. Func update status for project. It's going to be of type project with isClosed bool and then before we return any potential before we return anything you may want to return, but in this case we're not going to return anything. We simply want to mark this as async and say throws, because we're going to be able to throw an error in this method. So we need the call site to be able to handle that error, any potential errors. All right, and there we go. So now we have a function called update status for project with isClosed. Now, the first thing that we want to do, is, like always, is construct the URL that points to the endpoint we want to send a request to. So, to do that, we are going to say guard let URL equals URL with a string of base URL / projects / update dash status / and then string interpolation project dot ID. Then, if this doesn't succeed, so if it's not a valid URL, we will then simply just return. Again, much like with our post request methods, you could throw, and our get request methods for that matter, you could throw some kind of error indicating an invalid URL, but here we're simply just going to return to keep it simple, rather than throwing a custom error into the mix. All right. After we have our URL, we need to encode a patch request object into JSON. So the first step is to create that patch project object. We'll say let patch project equals patch project, and then pass it is closed. Finally, we are going to create a JSON encoder object. Let encoder equals JSON encoder. Now, if you're unfamiliar, the JSON encoder object pretty much just encodes a Swift object to its JSON representation. You can configure this encoder in any way you see fit if necessary, but in almost every case, the default way it does it, it works perfectly fine. All right. Then we need to say let data equals try encoder dot encode, and then we'll pass it our patch project object. And what this is going to do, as the name of the method implies, is that it's going to encode our patch project. Now, this can fail, so we have to mark it with try, like we've done here. Once we've encoded our JSON data, we need to configure the URL request. Now, we're going to do this using a URL request object. This object allows us to specify the HTTP method we want to use when sending our request, because by default, URL session, the class that we're going to use to send the network request off to the server, it does a GET request by default. So we have to use a URL request object with its HTTP method set, so it sends a different kind of request. Second, we need to set the HTTP body method of our URL request object, so our server has some data in the body of the request to work with when it receives the request. And then third, we need to set the content type of the request to application/JSON, so our server knows to handle the request body as if it was a JSON object rather than something else entirely. All right, so let's go ahead and do that. We'll create a variable called request, so var request equals URL request. In the URL request initializer, we pass it a URL, and then pass it, pass it our URL like that. Pretty simple so far. Next, we'll set the method of our request, so request.http method equals patch as a string. You could make that all lowercase, it'll work all the same, but I'm making it all capitals just because. Next is the HTTP body method. So we'll say request.http body equals data, like that. And then finally, we need to set the content type header of our request. And we can do this by saying request.setValue. The first parameter of setValue is going to be the value for the header field that we want to specify. In this case, it'll be application/JSON. And then for the name of the HTTP request header, it'll be C content -T type, like that. Perfect. Now, we actually need to send that request off to the server. And we can do this the same way we have been doing it, using destructuring and URL session. So just like in the last video where we sent post requests, we're going to use an underscore in our tuple for destructuring to say, hey, ignore any data we get back, and then we will have a response object. Now, much like last time, the response object is going to be a URL response object. And if we want to handle the status code of our response, which most of the time we do, we need to cast that to an HTTP URL response object after we get our response back. So, the first thing is we need to actually send the request. So we can do this by saying let, and then in parentheses, underscore, comma, response equals try await URL session dot shared dot data, and then pass it our URL request object. So now it knows where to send the request, it knows what method to use, it knows what the body should be, and what the content type is. So once the data method is called, the server will then be sent the request, and then when it receives it, it'll do what it needs to do to handle or satisfy that request, and then it will respond back with whatever status code is proper for a success or failure operation, depending on what the success or error message might be on the server. Because if you're unfamiliar, HTTP servers, when something goes wrong on the server, your app doesn't crash or anything like that. You don't get any specific client-side error, but the server returns a response with a status code. And if a status code is not in a certain range, specifically the 200s, then we know something went wrong. If it's in the 200s, we know something did not go wrong and we're fine. So, now that we've sent our request off, we need to cast our URL response object to an HTTP URL response object. And we can do that by saying guard let HTTP response equals response as HTTP URL response. If this doesn't work, we will simply return. All right. If it does succeed, then we have our HTTP URL response object, and we can check the range of the status code. We can say if HTTP response.status code is greater than or equal to 200, and HTTP response dot status code is less than or equal to 299. Or we can say status code is less than 300. If it's in the 200s, we know it succeeded, so we can print update successful. Status code, and then HTTP response status code update successful. Else, so if it's anything outside the range of 200 to 299 inclusive, we know something went wrong. So we'll print status code HTTP response status code update failed, like that. And that is our networking code. Pretty simple. At least for this kind of patch request. It might be a little bit more complex, depending on how you want to perform your patch request, but this is one of the most basic patch requests you could possibly send. And it's the perfect foundation for building up to a more complex request if you absolutely need it. So go ahead and save that. I'm going to go to, let's see here. Okay, this is well, I want to go to my sidebar view. So we can see here let's see. Here I have a button. Now this action is going to call an asynchronous method called update, or update project status. And this is what will send our request. Now, inside of this action, much like last time, when we called an asynchronous method upon a button tap, we have to surround it with a task. So task await update project status. Or update status for project with we'll say the inverse of project dot is closed. Just like that. Now, we need to actually write this method. Excuse me. and then once we have updated our status for the given project, we need to refresh. Our list. So right after, I can say await retrieve projects. So we're calling two asynchronous methods, one after another. All right. So now let's go ahead and code that method to update the project status. Here at the bottom of the file, we will create a function called func update status for project with is closed bool, and this will be marked as async. All right, and so inside of here, what we want to do is we need to then say so the first thing that we need is we need to call our actual method from our network manager. So we'll surround everything in a do block. We also need to provide a catch block, and we'll simply print error localized description. All right. Now, inside of our do block, we are going to do try await network manager dot shared dot update status for project with is closed. Just like that. And so we should be good to go. Let's go ahead and run our code. We have a successful build. Here's our application. Let's start with project 1. So if we take a look at the action menu here, we have open projects. So this indicates, or open project, this indicates to me that project 1 is closed. Let's go ahead and hit and toggle this action here. Now let's look at this again. We can see close project. Hit close project. Now we have open project. Everything gets toggled precisely how we intended it to get toggled. All right, so that pretty much does it for this video on how we can send patch/put requests to a API in our SwiftUI applications. Thank you all so very much for watching, and we will see you all in the next video.